Good morning students. Hope all are fine. Yes, in the previous class we began with what? Circles, isn't it? So the basic terms of the circles are explained, isn't it? Shall we do the recap of it? Yes. So first the definition of a circle. So we must consider the definition of a circle. So what is the definition of a circle? A collection of. A circle is nothing but a collection of points on a plane from a fixed point. So I can say a definition of a circle is a collection of all the points in a plane which are at a fixed distance from a fixed point, which are at a fixed distance. So fixed distance is nothing but the radius of the circle. And the fixed point O is called the center of the circle. So it is a set of all points in the plane. So, set of all the points in a plane which are at a fixed distance from the fixed point. So, the fixed point O is called the center of the circle, and the fixed distance is called radius of the circle. Radius of the circle. Okay. Then what else? It divides the plane into three parts, isn't it? So it divides the plane into three parts, that is interior region, exterior region, and the circle itself. Yes. So it divides into three parts. So it divides the plane lies into three parts. The circle divides the plane on which it lies into three parts. Circle itself, interior region and exterior region of the circle. There. So we consider the radius. What about the diameter? So a card that touches the circle at 2 points is called a card. So the 2 points, the line which touches the circle at 2 points, you take this as card of a circle. If the same card that passes through the center of the circle, then you will say, if the card, that is the card PQ, passes through the center of the circle, then you call it as diameter. So diameter is the card because that line touches the circle at 2 distinct points. Okay. So you call it as diameter. Okay. Then diameter is nothing but 2 times radius. How it is? OP plus OQ. Both are radius. So R plus R. And the diameter is the longest part of the circle, and it is also called the longest part of the circle, diameter. Okay. Then you will have the part of a circle. See, if I consider Mn is a part of the circle, part of the circle, part and the circumference of the circle. So you can say Mn is an arc. Part of a circle is called an arc. In this you will have minor arc and the remaining portion will become the major arc. Okay. If I consider MPN, that is the arc. Only a smallest portion you will have. In the complete circle, only the smallest part. So you can say this as minor arc. And the remaining portion AON. That is also an arc, but it is a major arc. That is a major. Okay. Then comes to sector. What is a sector? So chord and an arc. Chord and an arc. Chord means you know that touches the circle at two distinct points, and arc is a part of a circumference. Part of a circumference. Here also you can say MPN and MQN. Yes, you can say the sector is nothing but the region between a chord and either of its arc. That is called segment. See, the smallest portion is called minor segment. So I will have MPNM, that is minor segment, which has got minor arc. Then MQNM is major segment. Major segment. So minor segment is a chord and an arc. That is called minor segment. Major segment is major arc along with the chord. Okay. So MQNM is a major segment. These I have already taught you in the previous class, just the class before the fill in the class. Okay. Then what about a sector? Sector. Two radius and an arc. So usually we will say radii, isn't it? So the region between two radii and an arc. So you will get a sector. This is also minor sector and major part is major. Okay. So these and all you have already learnt in the previous class. And the chord that passes through the center divide the circle into two semicircular regions. Two semicircular region. Okay. So these we have done in our previous class. Let us move on to the fill in the blanks. The center of circle. So the first fill in the blanks is the center of a circle lies in dash of the circle. So where is the center lies in the circle? Inside or outside? Center always lies inside the circle. So I can write interior of the circle. Interior. The center lies interior of the circle. Then a point whose distance, a point whose distance from the center of a circle is greater than its radius lies in dash of the circle. center to any point on the circle is radius. So, greater than its radius means, see, this is radius. Greater than its radius means it will lie on the interior or exterior, outside. That is exterior of the circle. So that is exterior of the circle. What is the longest chord of the circle? So what is a chord now? The line that touches the circle at two distinct points is called chord. So a chord is nothing but that passes through the center of the circle is called diameter of the circle. So the longest chord So the longest chord of a circle is a diameter of the circle. Diameter of the circle. Longest chord is nothing but the diameter of the circle. There. An arc is a dash when its ends are the ends of the diameter. So an arc is a dash when its ends are, see, an arc is a dash when its ends are the ends of a diameter. Diameter means it's a chord that passes through the center of the circle. Okay. So AB is the diameter. So that R, the R which ends at, whose ends are diameter. So what this region is called? Yes, it is a semicircular region. So you will have semicircle. It is a semicircle. Okay? Segment of a circle is the region between an arc and a so segment is the region between an arc and what is this? Very good. Chord of the circle. Arc and a chord of a circle. Then a circle divides the plane. The circle divides the plane divides the plane on which it lies. Circle divides the plane on which it lies in dash parts. So it divides into how many parts? Yes, very good. 3 parts. Interior, exterior and the circle itself. Okay? Yes, it divides into 3 parts. Now, let us move on to the true or false. joining the center to any point on the circle is the radius of the circle. So the line segment joining the center, so that is center to any point on the circle, that is called radius. Yes, the line joining the center to any point of the circle is called radius. This is the radius. Yes, it is true. The statement is true. Then, a circle has many infinite number of equal cards. A circle has only finite number of. So, second one is a circle has only finite number of equal cards. So, equal cards will be finite, he is asking. No. So, you can draw both the sides. It is not finite. It is infinite number of equal cards can be drawn. So, this is false. So, a circle has only finite number of equal cards, that is false. It will have infinite number of equal cards. Okay. Then the third one is, if a circle is divided into 3 equal arcs, each arc is a major arc. No. See, the circle, if a circle divided into 3 equal arcs, each is a major arc. No, we cannot say. See, if I divide the circle into 3 equal arcs, see this one, if I have M, N, O. The other one is P, Q, R. And the other one is S, T, U. Are they equal? No, they are not equal. They are different. So, we cannot say when it divided into 3 arcs, they are major arc. No. It is false. The statement is, it may be equal or it may be a major arc, but it may not be a major arc. That is minor arc. False. Then, a card of a circle. The next one is, a card of a circle which twice as long as radius. So, if I draw a card, if it is 2 times the radius, that means this is radius and this is also radius. Then it will become the diameter of the circle. Yes, diameter is the circle which will have 2 radius. Isn't it? Diameter is nothing but 2 times radius. Yes, that is true. Then, sector is a region between. Next one. Sector is a region between the card and the corresponding arc. Is this a sector? No, this is segment, not sector. Yes. Sector is nothing but arc and 2 radii of the sector. That is not a sector. It is an arc and a card will become segment, not a sector. That is false. A circle is a plane figure on which it lies. Yes, it's a plane figure only. It is a plane figure. You can draw everywhere. circle. This is very helpful for your 10th standard also. Please learn properly. Then, angle subtended by a card at a point. See, take a line segment PQ. So, he is telling, take a line segment PQ and a point R, which is not on the line containing PQ. So, a line not containing PQ. Join PR and QR. Join PR and QR. You get a triangle, isn't it? Then PRQ is the angle subtended by the line segment. So I can say PRQ. Angle subtended. Where the angle is subtended at R, isn't it? Angle subtended by the line segment PQ. Angle subtended by the line segment PQ at the point R. At the point, angle subtended by the line segment PQ at the point R. Okay. So, where angle POQ and PRQ and PSQ. So, I can have, if O is the center, okay, so if O is marked and I have joined POR. Again, POR is the angle subtended by the line segment PQ at the point O. At the point O. Okay. So PRQ if I draw and PSQ if I draw. Again I can say POQ is the angle subtended by the line segment PQ at the point O. Then if I consider POQ is the angle subtended by the card at the center O. PRQ and PSQ. See, if PRQ and PSQ, because O has written, I can say O is the center, I can draw a circle. Okay. So I will have PRQ and PSQ are the angle subtended by PRQ and PSQ are the angle subtended by the line segment PQ at R and S respectively. Okay, R and S respectively. But RS lies in the major part of the circle. So major arc. Whereas SPSQ is like in the minor. So angle subtended in the circle is also to be explained. So first I have considered PQ is the line segment where R is not on PQ, that is outside. So let me join PR and RQ. So R is the angle subtended. So what? You get PRQ. So PRQ is the angle subtended by the line segment PQ. Now I have marked a point O, that is the center of the circle. So PRQ is subtended by an angle in the major part of the circle. So major arc. And if I consider PSQ, angle subtended by the line segment PQ at the, hope you have understood this. Let me continue in the next class. Thank you students. Take care of your health.